Hello everyone, myself V.V. Gopala, Assistant Professor, Department of Computer Applications, Aditya University. Today I am going to tell you about error detection by using the process of checksum. So here, after completion of the lesson, so I am expecting the outcomes from the students, what actually the introduction of checksum and what are the basic steps generally you follow in the checksum operation, and also to get more clarity I am going to show you a small example also, and I am going to tell you about what are the advantages and disadvantages of using checksum. So let us go into the details of the checksum procedure. Generally this checksum is meant for checking or identifying whether error is occurred or not. To that extent only we can able to use this checksum. It is only for error detection, not for error correction. So that too to a limited kind of the process what actually it is meant for to identifying the error, whether it is able to identify single bit error or multiple bit error or burst error. So to what extent it is actually designed, for what extent it is designed the finding out the error, only to that extent our checksum procedure can able to give you the clarification. So in this checksum process the steps are like this. First of all you take any message in the form of the binary format. Generally the message will be divided into some portions where every portion can be actually of 16 bits of size. Suppose you have a message and that message is divided into subunits. Every subunit is going to give you 16 bits of size of subwords, and all these subunits will be added, and these after this addition you are going to get the final value, and that is to be complemented. By using one's complement the sum will be complemented. So that can be referred as the checksum in this particular procedure. This checksum is going to add to the actual the data that actually we are sending. Along with the data checksum also we are going to transmit. So during transmission all the data word bits along with that the checksum will be carried to the destination, and at the destination means at the receiver side the received word with all the content, all that means all the portions of the data units, along with that the checksum will be again carried out the same procedure that is carried at the sender side. But because the sender side is actually adding the sum that is arrived and that complement of the sum will be added at the checksum, and because the same procedure if you carried out at the receiver side, then you find after finding out the sum and if you complement it, definitely you are expecting the checksum value as 0. If the checksum value is 0, then only you can accept the data. If checksum value is non-zero, then you have to reject the data. So this is the criteria that we can able to identify in the checksum procedure. So it is a very important, very simple procedure, simple addition and finding the sum. Just you complement it by finding the one's complement of the sum value, just you derive a value, and that is called checksum. So this is the checksum. The same process will be carried out at the receiver area. If checksum is 0, then you can accept it. If checksum is non-zero, you can reject the data that is received in this. So that is why this checksum is meant for the data that is for error detection. Now for identifying the actual process in a simple way, I am showing a block diagram here. So sender is having a message. This message is divided into a number of subunits called subunit 1, subunit 2. Let us say the n bits is a predetermined size of bits. Generally it will be of 16 bits. Every subunit generally will take 16 bits of size. These two, as far as the block is concerned, subunit 1 and subunit 2 are generally they are added, and you find some checksum. This checksum is now okay, taken into consideration, and that is this procedure will be carried out till all the subunits are over. That means subunit 1, subunit 2 are added, you find some sum, and after that you continue the procedure by adding of the values, and finally you, okay, take into consideration all the k units which are there in the total process, and thereby you can find out a sum. This is the final sum which is actually of n bits of size, because we are taken with n bits blocks. So, definitely the sum should be also of n bits. We will see what actually the procedure will be carried out once the sum is more than n bits, how you can able to do the actual the adjustment and all these things you can able to consider in this. So, the sum is of actually n bits of size, and you follow the ones complement of the sum that is there in this particular procedure. So, these n bits are actually complemented by using ones complement. Again you get n number of bits. The ones complement means you replace 0 with 1 or 1 with 0. So, that is the actual thing, you can call it as a ones complement notation. So, that is the actual process you can able to identify at the last okay, step, and that is called as the checksum. This value is called as the checksum. So, now this checksum is okay, added to the data. This is the position of the checksum, and data is also there. That means all the subunit blocks are actually okay, put it in this, and this is the checksum, that is the final figure that actually we derived at the sender. This complete thing is actually carried to the receiver. The same procedure is carried at the okay, receiver side also, and here also you will find out the sum, and that should be complemented. If this complemented value, let us say this is the complemented value, if it is 0, if it is becoming all zeros are there, then you accept it. If it is non-zero, if it is okay, it may be 1 or it may be a combination of 1 0 1 0 like that. So, you have to reject it. So, completely the last okay, n number of bits is going to tell you about okay, error is occurred or not. So, that is the way you can able to okay, say that this particular process is going to okay, help you to find out the detection of the error. So, let us take a small example here. So, there is at the sender side one subunit called as 10 10 10 okay, 1001. So, there is a subunit of 8 bits. So, once the sender is using 8 bits of subunit, the receiver also should use the same size only. So, generally of 16 bits of maximum size, but for the simple example purpose I am okay, showing you 8 bit size of okay, subunit here, and one more subunit that is there, and that is 0 0 1 1 1 0 0 1. So, this is another subunit. Okay. So, now you add these two things. So, what are the positions here? So, 1 0 1 0 1 0 0 1 and 0 0 1 1 1 0 0 1, you add them. So, once you okay, add them, so you find out, so because 2 ones are here, so 0 1 is carried, so 1 0 okay, again 2 ones are here, so it becomes 0 and 1 here, again 0 and 1 here, because 3 ones are here okay, the quotient is 1 and the remainder is 1. So, 1, so this is the thing. So, this is the value we are obtaining after summing. So, 3 ones 0 0 1 0. So, this is the sum value that is indicated here. So, already what I told you is this sum should be once complemented. So, once complemented in the sense wherever you find 0, you replace it as 1, wherever you find 1, you replace it as 0. So, that is why the entire thing is now okay, replaced by following the complement of the ones complement process. If you follow, then you will find out this 0 is okay, replaced as 1, 1 is changed as 0, like that. now it is becoming, so all zeros here, 111, 01. So, this is the checksum in our terminology you can call. So, now at the sender side you have two subunits of data, that is this, and the checksum you have derived in the process, that also you are allowing to transmit. This whole thing is actually carried to the receiver side. Again the process is carried at the receiver side also, because once you add subunit 1 and subunit 2, you will find out some value. So, that some value, let us say it is actually 000, 111, 01. This is the some value you are getting, and this some value, if you actually this is the some value, and this some value if you use some ones complement, all zeros are identified here, all zeros are identified here. So, let us say that, so you have 10, 10, 1 001 and 001 11 001. So, if you add, you will find out this one, this is already we added here. So, 111, 000, 10 plus the checksum what actually we have taken into consideration is 000, 111, 01. This is checksum that actually we transmitted to the receiver. Again you add, this is 1 and this is 1, 1, 1, 1, 0, this is also 1 and 1 and 1. So, if you see the sum value is including the checksum, if you take into consideration all the data units and the checksum, if you combine all, if you sum up all these things, you are getting all ones here. But what is actually the final step? You have to find out the ones complement of the final sum. If you write the ones complement of the sum, it is coming to all zeros in this case. So, once the checksum is like this, all zeros are there, then you can able to say that the data can be considered. If it is if any non-zero is appearing in this, then you have to reject the data. So, that is why this sender and receiver are following the checksum procedure to detect the error. So, this is a simple procedure of the checksum, where the all portions of the data units will be added, and you find out the sum, and you see that the sum can be once complemented, final sum will be once complemented, that can be referred as the checksum. So, that checksum along with the data units will be sent to the receiver. The receiver is going to do the same procedure, but the final sum, if it is if it is arrived, and if you find out the ones complement the final sum, if it becomes all zeros, then you can accept the data, otherwise you reject the data. It is a simple thing. For your clarity, I am giving one more example here. Sometimes so while adding you may get carry. So, that carry is to be added to the rightmost bit of the actual derived value. So, that this is the way how you need not worry about the carry value. So, we started with 8 bits, but after adding of the units, so you may get 9th bit also as a carry, and that 9th bit is to be added to the actual rightmost bit, and you can adjust that after adding that. So, like that you can able to you can able to get the final sum, and you get the ones complement of that. So, this is the way how you can able to take into consideration. Even if carry is there, you need not worry, you can adjust it to 8 bits as per the predetermined length by adding the leftmost bit to the rightmost bit. So, that you can able to get the required number of 8 bits. The same procedure is carried out as I mentioned at the receiver side also, and you see that the final sum should be all ones, and once you complement it, you find out all zeros. So, whenever you find all zeros here, so it gives an idea that you can accept the data, otherwise you have to discard the data. So, it is a very simple procedure by which you can able to take into consideration the data or you can reject the data. So, what are the advantages of the checksum? The checksum is a very simple procedure and which is meant for error detection, and because the steps are very simple addition of binary bits. So, you need not worry about the complexity in this, simple and very fast to operate, the addition values you can able to identify, and also requires minimal computing resources. So, because addition only we are taking into consideration, so you need not worry about the much of coding in this, and also you need not worry of complex resources that are necessary for this. So, simple minimal computing resources are sufficient for this checksum procedure. Coming to the disadvantages, so because it is limited only for error detection, you cannot find out error correction. You cannot do error correction by using this checksum. So, only thing you can able to detect the errors, that too to a limited extent. That means, if 2 bits are altered their position, so again you cannot get the checksum as you cannot actually depend on the checksum value, which may give you a wrong impression. You can accept the data, but actually speaking the data is corrupted, because even number of bits altered in the procedure. If you see that in the procedure, suppose even number of bits are altered, that means if the 1 is altered as 0 and this 0 is altered as 1, then you cannot identify the error, because the checksum will give you the actual all zeros, but it gives you a wrong impression that the data what we have received is wrong, because of the checksum that is actually happen to be all zeros, but actually speaking there is an error in the data. That means, when 2 bits are altered, this will not give you correct logic, but if you see odd number of bits are altered, then you can find out the error that is occurred. So, this is a limitation you can call in this case of the checksum, that is a disadvantage, limited detection, and no error correction is possible, and also not secure, because the process is very simple. The hackers may intrude into the actual the concept of or intrude into this process, and they may do some kind of damage to the data that is in the transmission. So, that is about the disadvantage of checksum. I hope by this the student is able to understand at least what actually checksum is, and what is actually the actual process of checksum operation that is there, and also how the example is giving you some clarity about taking into the number of bits into consideration, how you can able to add the data units to get the final checksum, and also the checksum, how the checksum is finally declared to accept the data or reject the data. So, based on the checksum value is very important, and after that we are able to identify what actually the advantage of going for the checksum, and how this checksum is giving you some problems, disadvantages in this case of the checksum procedure. So, that is all about the checksum. Thank you.